Okie doke. So, pollution. The EKC, what's that? It's the environmental Kuznets curve hypothesis. For many pollutants and many economies, we see a pattern of rise and fall in polluting emissions. So in this picture, we see sulfur emissions to the air in the UK. Yeah, sorry, there should be a label saying that, but this is for sulfur emissions to the air in the UK, okay? And we see a steep rise, more or less following UK GDP. And this, because this is more or less a straight line, ish, a straight line would be a constant doubling time, right? Constant percentage growth, because this is a log scale. But then from around about 1955-ish, when the Clean Air Act was brought in, emissions of sulfur collapse. And in the year 2000, we were more or less back to the level of emissions we had in 1850. And the trend was still going down, yeah. Here we've got CFCs, freoner, at a global level, and we've got global GDP. This is UK GDP, of course. And here we see a much steeper rise than GDP growth, because basically we only sort of discover CFCs and what they can be used for sometime in the early 1900s, and then it's like, oh wow, these are great. We start using them more and more, the growth is huge. And then somewhere here in the early 70s, I can't remember exactly, we're like, there could be a problem here. And within about 10 years or so, or yeah, I'm not sure exactly, but 10, 15 years of the initial scientific discoveries, it's like, right, we just got to ban this, we have to stop. The Montreal Protocol here came into force, and use of CFCs absolutely nosedives. Okay, this is just two examples, but I could have shown you lots of other graphs. Okay, we see this a lot in the data. So what's going on? Well, traditionally people have looked for some kind of pattern to this, is there a turning point at a particular level of GDP or some particular time, and we haven't been able to find that kind of simple pattern. And that's not really surprising, if you ask me anyway, because if you want to look for a pattern, you should start with a theory, right? Like, what's the real theory behind this? And then, given that theory, what exact pattern do we expect to see? We haven't really had a good theory of what's going on until relatively recently. Okay, but I'm going to take you through the basics of that theory today. Okay, but first, another empirical paper, this one by Shapiro and Walker, and they basically look at why did polluting emissions decline? Was it because of more strict regulation? Was it because of environmental productivity, that we just did things so much more efficiently that there was much less pollution per unit of stuff we made? Or was it to do with trade? And they show that it's almost entirely due to regulation. If you don't introduce regulations like pollution tax or banning certain technologies or whatever it might be, pollution keeps going up. And this actually fits nicely with the analysis of the minerals. Because remember, for minerals, we saw that the rate of use of minerals just goes up and up, right? If the price stays constant. And if we think of pollutants flowing from mineral use, well, if we just let everything be, so to speak, mineral use goes up, pollution flows will also go up. But when policies are brought in to discourage emissions, the price of using the polluting mineral goes up and its use declines. Okay, so well, that would be a simple idea behind what's going on. Okay, I've got to decide where to stop the video. Yeah, okay. So what might the mechanism be more specifically? So here's another variation on our figure. It's similar to the one I showed you in the last video, or broadly similar. Right. Once regulations are brought in, how do the reductions in pollution flows occur? And we're going to use this figure to get our heads around that. So this is a miniature version of the figure. From the solo paper that we've mentioned quite a few times, we can immediately think of three possibilities. One would be changes in consumption patterns. So reduced consumption of resource-intensive goods and increased consumption of immaterial goods. Another one would be efficiency increases, so that we keep consuming the resource-intensive goods, but we reduce the amount of resources we need to produce them. Okay. And the third one would be substitution in production. So we use some other technology which leads to less or even zero pollution. So maybe instead of coal, we use oil, or maybe even instead of oil, we use wind. Okay. Or maybe instead of burning coal with just burning it straight up, we put a scrubber on the chimney, flue gas desulfurization, FGD, to clean up the sulfur if we're worried about sulfur on the way out. Okay, that would also be like a different technology. Instead of coal, we use coal plus flue gas desulfurization. Now, the literature says pretty clearly that historically, almost all these big reductions in pollution, they've come through technology rather than composition. So it hasn't been that we've changed the choices of what to consume. It's been either efficiency increases or shifts between inputs. Which of those two do you think is the most important? Okay, try and think of some concrete examples. Okay, it should be pretty obvious if you can think clearly about concrete examples. I'm going to leave that hanging, but it will become obvious during the rest of these videos. Okay, let's see. Okay, so I'm going to stop there, and then we'll carry on in the third video shortly.